Hello, good morning, buen dia, and bonjour, everyone. Thank you very much for participating in our first Aquaculture Talk webinar. I'm so pleased to have so many people registered for this meeting. It's also very nice to see all the interaction on social media, texts, emails from colleagues all over the world. Thank you very much. As you might know, my name is Kurt Servin. I work for Jefo Nutrition as a consultant, together with my friend and colleague Hervé Lucien-Brun. Both work at the Aquaculture department. Please let me introduce our guest of honor, Dr. Sachi Kaushik. Dr. Kaushik, who was Director of Research and Head of the Fish Nutrition Laboratory and Hydrobiology Station at the National Institute of Agriculture in France. He is internationally recognized as a scientist with a very strong publication record. As for today's meeting, we will take 35 minutes of your valuable time to present Dr. Kaushik's presentation related to sustainability in aquaculture with a focus on carbon footprint. Today's meeting will be short. We will try to make the most of your time. Please feel free to ask any question, fill the question box, and we will come back to your question after the presentation. This presentation will be online available as for video, and we will be able to share this presentation. Please, Dr. Sachi, you can start whenever you're ready.
Good morning, good afternoon, everyone. So for the rest of the world, so I have a pleasure of being invited by Jefo to talk on aquaculture and the carbon footprint issues. One of the things that I want to start with is the commercial aquafeed production is expected to grow by more than 25 million tons within the span of next 5 years. So this is something which is very important. And at the same time, commercial aquafeed production, there is also other things called the farm-made feeds in different countries, especially in Asia. And also 3 to 6 million tons of low-value fish which are fed directly to fish from different parts of the world. As a nutritionist, I want to say that if we need to produce more and more feeds, we should know what the different species require. This is the part of the nutritionist job. And we cannot rely on a few selected ingredients to develop such feeds. This is the feed company's job. As I said, that if we want to rely on some of the ingredients which are commonly used in intensive aquaculture, with the fish meal and fish oil, these are from captive fishery, and they are not infinite sources. There's about 5 million tons of fish meal and less than 1 million ton of fish oil. Over the past 10, 15 years, people around the world, and especially myself also with a lot of colleagues from Europe through different European projects, we've been able to state what is called the reliance on captive fishery derived feedstuffs can be reduced. I give here two examples of Atlantic salmon and gilted sea bream, a totally marine species. In these studies, what we have seen is that we can considerably reduce the fish meal and fish oil level. For instance, in the final stages, we have only 2% fish meal and 2% fish oil, even for Atlantic salmon. And for totally stenohaline marine species like gilted sea bream, less than 5% fish meal and 2% fish oil, with very good growth and very good feed efficiency or feed conversion ratio, what you say around 1 or 1.3 in the case of gilted sea bream. So this is possible. It's been done with number of species through not only by ourselves, with the colleagues from different countries in Europe, but also in other parts of the world. So we made a statement like this: the level of fish meal in the feed over the past 25 years has come down significantly. Even the carbs, they used to have about 10%, is less than 1% now. And bass, bream, salmon, trout, and so on, they've been coming down. And the same applies to the fish oil levels in the feed for bream and bass, salmon, or trout. If you take an example, is the evolution of salmon feeds, Atlantic salmon feeds I'm talking about, over the past 25 years. This is a recent document from Norway. You can see this fish meal and fish oil was practically about 90%, and now it's less than 25%. You have plant protein sources, plant oils, other cereals and other sources, macro ingredients, and so on. So what is the decrease in the fish meal and fish oil levels? This raises to other questions. An example is the long-chain polyunsaturated fatty acid levels in the fish. Over the past 15 years, it has come down somewhere from 3 grams per 100 grams of EPA and DHA to about 1.5. So this is the plan. This is one of the major questions which come up. But we know from science that we can tailor the fatty acid profiles using the finishing feeds. At this stage, for instance, at the last periods before slaughter, you can modify the fatty acid profiles using feeds which are rich in these fatty acids. There is solid science behind, but practice is not yet clear. Another advantage of this reduction in the fish meal and fish oil levels is also the polyaromatic hydrocarbon levels are going down. So as I said, fish and shrimp, they need omega-3 long-chain polyunsaturated fatty acids, but the global availability of these fatty acids are very limited from conventional sources. But there are novel sources like microalgae, GM, camelina, and so on, which can alleviate pressure on fish oil. Even in shrimp, this is an example of studies undertaken by myself with one of my students some years ago to grow monodon fed feeds with greater levels of fish meal with no differences in growth of performance or feed utilization whatsoever. This is a recent evaluation which was made by Dr. Hua from Australia on the amount of fish meal levels in the feeds, which can range from 1%, mainly in the carbs, up to 30% in the eels, for instance. So there is a big range of differences, but the levels are relatively large, from 1 to 15% majority of fishes, except in exceptional cases like the eels, where you have 30%. But this leads to other questions in terms of environmental impacts. Aquaculture now competes for crop resources, terrestrial plant products, with livestock, energy, human consumption, and so on. So there are a lot of questions which come up. Similarly, in the past, about say 10 years ago, there was this concept called fish in, fish out ratios. I didn't know that. When I say Fifo, it was an acronym for me for the first in, first out. But this was invented by some of the NGOs who are not very much happy with aquaculture. They wanted to calculate the quantity of wild fish required for feeds by the quantity of farmed fish produced, taking into account the amount of fish meal and fish oil in the feeds and the yield of fish meal and fish oil from capture fisheries, and taking into account the efficiency at the farm level, feed-gain ratio, for instance. If you take this yield, this can range from 20 to 25% of fish meal. For 1 ton of fish, you may be getting about 20 to 25% of fish meal and 5 to 12% depending on the season, depending on the species, the fish oil. In feeds, when both fish meal and fish are used, for each unit of fish oil, there is also some fish meal available, useful for other feeds. Another issue is that food fish co-products. Since at least 5 years, trimmings are recovered from converted into fish meal and fish oil, and they are also used in many fish feeds, at least in Europe. Aquaculture crop products, salmon oil, can also be used in aquaculture. Going to the environmental impacts point of view, we know that aquaculture relies on good quality water. It's so important for aquaculture, more than any other food production sector. Aquaculture relies on the good quality of the water. But knowledge gained on nutrient flow dynamics, nitrogen, phosphorus, can be applied at the farm level using appropriate tools and models. They are available. There are even companies which are providing such services, which has been verified at the farm levels, but can be extended across the sector at the regional level, at the ecosystem level. There are a number of questions which come up, sustainability issues. I'll be talking about it in the next few slides. Tools such as life cycle analysis, carbon footprint, environmental footprint, water footprint, environmental performance, all this catchwords. One major issue is that we have to ensure that good resource utilization efficiency. That means the amount of resource you put in, you should be able to get it much from there. And there are certifications, ecosystem approach. There are a number of multi-users, competition between users, end users, and so on. If you take the carbon footprint, for instance, this is an example of beef, which is commonly considered as the extremely high in carbon, having a high carbon footprint, 16 to 40 kilograms of carbon dioxide per kilogram of edible product. And fish is relatively low, but very close to chicken. But the range of values can be very high. We have to choose the right yardstick to calculate the carbon footprint. For the same product, there can be considerable variation between different data sources. And this is one thing which is important when we are trying to calculate the carbon footprint, which database that you're going to use to rely and develop the carbon footprint. In aquaculture, I myself did with one of my PhD students long back. At the farm level, feed and water use contribute the most to the carbon footprint. And within the feeds, it is the feed ingredients which contribute the most to the carbon footprint, more than the factory and other things. So here's an example: high fish meal with other products, low fish meal, no fish meal, and so on. See, for instance, contrary to what you think, sometimes when you have no fish meal at all, then there is the carbon footprint can be much higher. So anyway, the crop production, for instance, has high carbon footprint. At the farm level, feed and water use, that means anywhere you are trying to use the feed gain ratio, improving the FCR, this is going to improve your carbon footprint. More than carbon footprint, there is another concept called the life cycle analysis, from cradle to tomb. So here, again, as part of different European projects, we have been working on the life cycle assessment of farmed fish fed, low fish meal and fish oil levels, standard feeds against low marine. This is an example with Atlantic salmon. So you have very similar things, different criteria which are used: acidification, eutrophication potential, global warming potential, terrestrial ecotoxicity, net primary production use is very much linked with phytoplankton, water use, land competition, and so on. And then different criteria which are used. And when we compare the standard feed, or it means high fish meal, fish oil to low fish meal, fish oil diet, one striking, two things which strike is the net primary production use, which is reduced because we are using less and less of fish meal and fish oil. That means the use of primary production in the oceans is reduced, whereas there is an increase in land competition. So when this was tested with a number of species: trout, salmon, sea bream, sea bass, and even Indian carp, and the common carp in Europe. Compared to a feed with fishmeal and fish oil, use of plant proteins and oils reduces this net protein primary production use. It doesn't affect much the global warming potential, but increases the dependence on land and water use. In all animal production, we have these three concepts of indicators of sustainability. You have the environmental, that's what many people talk about. They forget the two important aspects is the economics and the societal issues. In terms of economics, you've got to think about the market cost and demand, husbandry, ingredient costs, technology, the volatility of feed cost, for instance. And when it comes to societal issues, you have to think in terms of acceptability, image, health and well-being of not only animals, but also the people who are eating the food, nutritional quality, and possible levels of contaminants and the reductions, that how to do it. And the environmental issues, of course. Simple thing for aquaculture has been visible impacts. I don't want to see the farm. Invisible impacts, what is happening underwater, and how efficient is the production. And so there are other tools like the life cycle analysis, as I just mentioned. So all these three concepts have to be taken into account. This is what we were thinking about 10 years ago. New concepts have come in where the wheel of sustainability, based on what we call the certification schemes. There are a number of certification schemes now, and they are trying to use the same concepts of life cycle analysis or the sustainability issues, taking into account economics, environment, culture, the society, and governance, that's the management. And another one, which is very recently developed in the UK, is called the One Health approach. That means ultimately, whenever we are producing any food, it is for the human being. So you've got, of course, the importance of organisms that we are rearing, environmental impacts, going from the ingredients to the environment at a large sense, and the people who are going to use it, and consumers to medical field and so on. So this is called the One Health approach. When we talk about aquaculture, one issue which comes very often is the diversity of species. Compared to terrestrial animals, where we are confronted with very small number of species, aquaculture is confronted with, some people say that about 200 species or 300 species which are grown or at least considered as having potential for aquaculture. And we also use terms such as herbivores, carnivores, and omnivores. I have some consideration in terms of the etymological. Carnivore means the eater of meat, and some people define it that at least 70% of your food comes from meat, which is never the case in any aquatic organism. So we got to reason more in terms of the trophic levels. Here is a nice presentation made by Duarte et al. Some years ago. We're trying to see on the left side, you have this agriculture food chain and the seafood chain, that means aquatic food chain, food of aquatic origin. For instance, in the land, almost all food that we eat comes from low trophic levels, T2. In the seafood, which is this food of aquatic origin, is drawn from relatively high trophic levels. There are, of course, some blue mussels and things like that which are eaten, but majority is coming from high trophic levels. And the human trophic level itself is calculated to be somewhere between 2.5 or so. But when we take the global aquaculture, it's still mostly from low trophic levels, whereas capture fisheries, of course, is very much linked to high trophic levels. So people have a confusion very often. The thing is, we've got to go into low trophic species and so on. But what is really happening is the aquaculture is really doing very much. And with the changes, as I said, in the feeds that we are making, it is really becoming a low trophic level. Farming systems also change. We have offshore cage farming, ponds, and here is an example of a totally recirculated aquaculture system. But when we talk as a nutritionist, data on nutrient requirements for all species and stages, are they affected by the farming systems? When it comes to feed manufacture, we've got to ensure the physical quality of feeds. If the feeds are here to distribute it to the different cages, we've got to ensure the physical quality and the nutritional value of feeds be ensured. And there are a number of modern tools, feeding strategies, tools, models, and now since a few years we're talking about precision farming using artificial intelligence, smart aqua, etc. When it comes to the system pond rearing, which is very much present in many species, especially for shrimp, for instance, recirculated aquaculture systems, etc. Nutrients and excreta are in the same environment. How do we manage the micronutrients in the water? How do we ensure the physical quality of feeds and the feces decantability in the recirculated aquaculture systems? As a nutritionist, I've been involved in developing what we call the high nutrient dense diet, H&D diets. Now talking about high fecal decantability. So it's kind of a reverse. That means you've got to put some binders which will be less nutrition dense, but it will be having an efficiency in terms of ensuring the water quality. Aquaculture and is also reliant on very much on genetic improvement. Selection for weight gain has been undertaken with a number of species over the past 30 or 40 years. Long back, there have been Czech Republic and in China, even genetics works. Atlantic salmon, trout, salmon, coho salmon, tilapia, carps, European sea bass, shrimp, and everything. Almost 85 to 90% of European production is based on specific breeding programs. There are more than 30 of them. On the left side, I'm giving an example of the French selection program made by Jefo some years ago. So you have a population where you have a natural distribution. You have the very low performers and very high performers. Second generation, you test them, you remove this and you have the low and low, and on the other side, you have the high performers. So you can have what you call individual selection approach called PROSPER, repeated sampling and repeated testing, has been very efficient in developing number of well-performing species, both rainbow trout, sea bream, and sea bass. When applied quantitative genetics, family selection or individual selection like this one, you have cytogenetics, production of triploids, hybridized, many of the tilapias, clones, in France, notably with isogenic lines of rainbow trout. And there are other tools, marker-assisted selection or genome editing, which is coming up these days. And there is also transgenic fish. So what are the criteria which have been used for the selection? I said weight gain. Now they also have morphology or deformities, especially applicable to marine species. Disease resistance, resistance to ectoparasites, for instance, in Atlantic salmon with the sea lice, processing yield, flesh quality, as affected by the fat content, as well as the long-chain polyunsaturated fatty acids, pigmentation, Atlantic salmon, maturity, fecundity, and so on. But one major issue that's challenging for everyone is how to improve the efficiency of the utilization of the feeds. There are a number of initiatives currently going on with more or less success, and also to use novel diets containing low levels of fish meal and fish oil feeds. As I said, fish production is as food for man. Both aquaculture and captive fisheries are contributing towards. This is the only food sector where you have capture and culture compete against each other or complement each other. There is a study made by some colleagues from Stirling, UK, on domestic consumption in selected countries and the exports. And their conclusion is that at a global level, the sustained growth of aquaculture is not due to the demand from a small, wealthy segment of consumers, but because it caters to the local needs. That's a very important issue because when we are growing fish, it is for meeting the nutritional needs of the people. Meeting local nutrition needs should be a priority. There are a number of societal concerns, food safety issues, labor issues, level playing competition. So I'm doing it here, but they have a much lower standards. So they are exporting those fish to my market and so on. Circularity is a big theme these days. And what I say is I call what you call fish miles. We've got to reduce those fish miles. And there is another thing which is coming up these days is increasing biopower in majority of these developing countries. So fish as food for man, we got to think more in terms of local nutrition needs than just for export. There are initiatives in different parts of the world where this is becoming a more and more important. And we also had contribute to the UN Sustainable Development Goals. So aquaculture is considered an efficient animal production sector compared to different production systems, be it energy or protein. Aquaculture, the fish are more efficient. Of course, there's eggs. Chicken eggs or hen's eggs are more efficient than others. Feed gain ratio, fish can be 1.2 to 2, but very often in many situations, this is much higher. Chicken at the global level is about 1.8 to 2. Protein retention can be very high. It can be more than 40%. Edible yield in fish ranges between 35 to 60%, which is not the case in chicken. Water use, and this is another environmental yardstick, is aquaculture is definitely more efficient than others, but it can be more efficient. So we made a document a number of years ago on improving productivity and the environmental performance of aquaculture. Finally, I would say stop here with the current sustainability bandwagon. We've got to go beyond that. Produce healthy food for man in a resource-efficient manner. Feed composition is the fastest changing environmental factor. We've been involved with the least cost, the majority of feed companies, they do, but we've got to take into account the least risk to long-term sustainable issues. Optimal diet formulation is a moving target. That means it changes from time to time because of the ingredient availability, cost, and etc. There is a clear trend. High levels of fish meal and fish oil is no more the case. Why should we use terrestrial plants? Why not go towards marine agronomy? That means all marine food, aquatic food, discards, algae, and so on. And we can also exploit all possible nutrient sources and feedstuffs. With regard to the choice of species, do we have to go to low trophic levels? I don't think so. Sound nutritional principles make even high trophic species to be a low trophic depending on the kind of food that you supply. Fast growing species, yes, that's a requirement. We need to have fast growers. Here, genetics can play a number of roles, but genotypes and farming systems are variable. And how do you do the analysis of feed-breed interaction when the changing composition of feeds is occurring continuously? So this, again, an issue for scientists to do that. We need reliable biomarkers, non-invasive biomarkers for growth, feed utilization, nutrient efficiency, and so on. We've got to use the analysis of biological consequences, not only in terms of growth, but in terms of health and welfare and so on. Societal demands have to be addressed, climate change, and the UN Sustainable Development Goals, as I said. For instance, when I say Sustainable Development Goals, there is goal number 14 called life underwater. But this can be combined with reducing hunger, a number of other things. So aquaculture contributes and can do more towards achieving the UN Sustainable Development Goals. I stop here for thanking you all for your patience. Thank you very much.
Thank you very much, Dr. Kaushik. I have to say I'm very surprised. It is a very up-to-date, advanced presentation in terms of sustainability. We have a number of questions, plenty of questions, but we will narrow them to a few. Hervé, any comments on the presentation?
Oh, I think it's a very good one, and for one time we not just talk about the fish meal and the amount of fish, etc., but all the different possibility. It's a new approach for us. I think so.
I have to say, as a domestic farmer, a Mexican farmer, I was very touched by your presentation. I really love what you say, the fish miles, reduce the fish miles. That's a very clever one. That's a really smart one. Let's carry on with a few questions. Some of the most, the more often questions they said is, people keep asking how to achieve sustainability through fish nutrition. That's a very big question, I have to say. And also how farmers can improve sustainability, changing feed alternatives. Any comments about that?
Yes, as maybe I was not very clear. What I say when you say talking about sustainability, we always include only one aspect. It is the fish meal and fish oil when it comes to aquaculture. The use of plant proteins is not all that sustainable. As I said, when it comes to land use, water use, chemicals used for production of, let's say, any cereal or oil seed, I don't want to give the names of anything, oil seeds are very commonly used, which is the soybean oil, for instance, oil seeds, and that is what you make the meal. And so you have a number of such things. Whenever there is an issue of, this is what we call the land use and ecotoxicity issues. So it's not necessary that reducing the fish meal and fish oil is only the one issue for sustainability. We have to take into account all the different aspects. That's why the life cycle analysis is a very good approach, is one good approach. And people are now trying to incorporate, in which we did not do at that time, was the societal issues. How much is for the local people, for job creation, food production, provision of food for the local communities. So these things have to be taken into account when you talk about sustainability. It's not just one ingredient against another. I'm not sure if I'm clear.
Yes, actually, you answer more than one question. Because people keep asking, how do you see alternative proteins versus growing needs for fish marine ingredients, which you basically just explained. Also, one of the questions that people ask is, could be the insect protein an economical valuable source of protein?
Yeah, okay, yeah, that's a very good example. Insect proteins, yes. When you start a lecture on insect proteins, we always say our culpability, that means our guilt. We are throwing out so much of junk.
Okay.
Yeah, that's how we start the story. And this can be improved by exploiting this organic waste into excellent, efficient protein production system. That's true, which is correct. But unfortunately, if you want to bring it back into the human food cycle through supplying it to the fish, we have to be careful that it is almost like producing another animal to produce fish.
Okay.
So insect production also has to apply the same standards of food quality and feed quality. We have to ensure that the insects which we are producing do not have the contaminants. It has all the good things, and we don't want the unwanted stuff. So it's an efficient production system in terms of efficiency of conversion of nitrogen. And there are some other issues which come up is in terms of the fatty acids. Because when you do a comparison with fish meal also has a fish oil as a component. It brings the fatty acid composition. So It is a very nice question. So, and that, at least from the European point of view, I have some slides I don't want to show here. It is used as more for tapas.
Okay.
Yeah.
The snack we use in Mexico are very popular.
Yeah, in Mexico is popular because it's all wild animals that you are growing and so on. Okay.
Exactly.
And here, sometimes I have even in my own place, not too far from here, a packet of 100 grams is €6.
Okay.
It's more for yuppies. Okay, you understand. The thing is, I'm not criticizing. The concept is very good, but the way it is used today is they have to make what you call value-added products.
I see.
You understand? So,
yes,
the concept has to be taken into account, and there are other issues like there are single-cell proteins coming from gas or methane and other things. Okay, there are other things which can be of interest also.
Okay, so based on your experience, if I understood well, the fish meal is not going to go away from the feed meals. I mean, aquafeeds.
You don't have to. See, it's a question of availability of fish meal. The whole globally, you cannot have more than what is available today.
Exactly.
Exactly. And if aquaculture has to improve, you have to use it in the most efficient, intelligent manner, only for periods of, let's say, reproduction, early life stages. So you don't need, so you have to make it intelligent use of such precious products.
Of course. Also, we have fish meal coming from rendering, for saying tilapia meal.
Yeah, but the problem is then it becomes more or less high ash content and there are other issues.
Yes.
So from species to species transfer and other questions. Yeah, I mentioned in my lecture about this Fifo. Nowadays, yes, the rendering, but then the total volume of fish meal is still the same. If you go by the numbers, it's strange. We are still using rendering products, but the total volume remains the same.
Exactly.
There's something wrong somewhere.
Okay. Well, hopefully we will figure it out. Oh, well, thank you very much. Hervé, any questions?
No, we talk a lot about limiting the fish meal for reason of resources and reason of prices. Most of the time, in a lot of countries, when they talk about vegetable protein, it's only soya.
Yeah, no. That's not. Yes, please.
Now we have the problem that the demand of soya is increasing more than the production, and the price become very high. So we will have another economical problem with the aquafeed soon.
No, sure. No. That's why I was always saying I didn't when in the initial first one or two lectures, slides, I said reliance on one or two selected ingredients is not good. So it can be soybean meal, it could be, and when you do a comparison between soybean meal and fish meal, there's already a big difference in terms of the total protein content. So, if you want to replace 1 gram of soybean fish meal, then you may have to, just in terms of protein, you may have to support 1.5 grams of soybean meal. Okay, that's why you have other products which have been developed, excellent products like soy protein concentrates, isolates, and a number of things. And it's also applicable to other oilseed meals.
Dr. Kaushik, we have a number of questions coming in non-stop. Okay, I would take advantage from you and ask some just to show a little bit. One of the people here say, where do you see the next generation moving in terms of meat choice? Artificial meat, plant-based meat, or how sustainable is it?
Yeah.
Okay.
No. No, this is to see again the artificial meat is because I know how to do it. It's not because there is a need, but I know I can make it.
Okay.
3D printing of food is already there. Okay. But is it really required? It's what you call high-end thing. So there are people who are still having not enough food to eat, I'm talking about when we talk about fish, especially. There is some very nice things about the like 1,000 first days of where you have to eat fish so that you can have some people in developing countries where can afford to have fish. And now we are talking about inventing artificial food, which is not really required, because if you take some consideration, some people, some population, they have very little animal meat.
Okay.
Total animal meat is very small, and this is where you got to take it into consideration. This must be a very efficient, good quality animal product. So fish is one, and this is where we've got to push towards eating fish. The question comes very often: why do we make fish meal instead of giving them to the people itself?
Okay.
Yeah. So this question comes up very often.
But yeah, different concept. I agree with you. Another question, Doctor. Why European consumer is still not confident about aquaculture products? What is your opinion?
No, it's the contrary. The European country is very much in the global average. They're eating, yeah, there is eating more. Yeah, there's nothing. If you like, you go to the Eurofoma website and things like that. Yeah, there is, because the problem is you don't realize what is farmed or not. But you go to a restaurant and say this turbot is coming from wild always, but there's no wild turbot anymore. It's
Exactly.
the Atlantic salmon, the global Atlantic salmon, wild Atlantic salmon is about 3,000 tons.
Okay.
Yeah. So whereas you have about 3 million tons of Atlantic salmon produced around the world, all salmon, that's steak included.
I agree
One
with you.
It's a confusion in the mind of people. Yeah.
Yeah,
one problem
confusion.
with the European consumer, they always complain against the aquaculture product, but they are the French are the main buyer of the salmon. They eat a lot of pangasius. They eat a lot of shrimp. And if you ask them, do you like pangasius? They will tell you, no, pangasius is very bad. But they buy 45,000 tons per year.
No, yeah, but this is no, but this is it's not a very common. There are issues. This is what I call is the European producers. I mean, we don't increase. That's sea bass and sea bream is increasing now,
Yeah.
but the issue is very often what you call level playing, because it is produced cheaper elsewhere with other standards, whereas the European standards are considered to be better than what is being done elsewhere. And this is the kind of what you call arguments which are produced by the European producers, for instance. It's not the consumer who is asking for, and they are, of course, naturally they'll think of in terms of the seafood miles or fish miles or whatever it is, because then I don't buy it from Chile, I don't buy it from Vietnam, I buy it from locally. Okay, so unfortunately, there is no tilapia or panga produced in Europe.
Exactly. One more question coming from Mexico, Dr.
Oh, yeah.
Kaushik. How can high trophic level aqua species be raised in a sustainable way?
Mm-hmm.
That's
Yeah,
a
to
question
make
from
them,
Mexico.
yeah, this is what my thing is. It's a kind of a high trophic level, yeah, as I said. But thing is,
Hightrophic.
yeah, uh, meager. Is it high trophic or low trophic? No? Yeah, is it high trophic or low trophic? Because the only person who can talk about is the fish base. You know, it's a very good database, Fish Base by Daniel Cody, and that's where you have the exact situation of the trophic levels of different species of fish. And myself and our scientists across the world have developed feeds with less and less reliance on animal products. Okay, fish meal. But if you are using poultry byproducts, is it high trophic or low trophic? You understand? So the question of species is one thing in nature, but when you are putting it in the farming circumstances, it is the intelligence of the farmer, intelligence of the nutritionist, intelligence of the feed manufacturer, which makes the difference.
I see. So
So
it's a matter of perspective.
Yeah, because hightrophic fish in nature can be made to low trophic, giving them the proper kind of nutrients, not the ingredients. Animals don't require ingredients, they require nutrients.
Nutrients. I
That's
agree
why.
with you. Wow. We can stay here for another hour. Just so many questions. Unfortunately, I say we leave the rest of the questions we can answer by email. All the attendees will have a copy of the presentation, of course. And if you agree, we can share some of the questions with you and we can ask, we'll
I'll try
reply
to
later.
answer most of them. I'll try to answer to my best of ability. Yeah.
Thank you very much. Well, indeed, it was a very good presentation. People are very into the talk and just they keep non-stopping.
Thanks. No,
Well done.
no, it's been, yeah, it's too short anyway. Thanks. Okay.
Hmm.
Yeah, thing is, unfortunately, it would have been nice to go to Mexico and do the lecture there. Unfortunately, this COVID stuff blocks us everywhere. Please keep safe. Yeah, hope we can meet somewhere.
Anytime, whenever you have a
I'm
chance,
talking to
you're
the
welcome
whole
to come
population.
to
Thing is, people
Mexico.
who are not only you, but also from other attendees.
I see. Well, before we leave, I want to thank Hervé Lucien, my good friend. Of course, you, Professor Kaushik, for your time and effort to attend this presentation. Also, our good colleague Annie for all the effort to put this project together, and obviously Jefo Nutrition for the support and the infrastructure to hold this meeting. Thank you very much.
Thanks for giving me this opportunity.
Thank you.
Bye bye.
Bye
Thank you
bye.
very much, Dr.
Au
Kaushik.
revoir.